folks, welcome to 7.3 part 1. And in 7.3 we're going to be talking about something called vectors. And so what I want to start off by talking about is the difference between a scalar quantity and a vector quantity. So, things that we can measure things like area or volume or length or temperature, and all of those values have a magnitude. Okay, so all of these have a magnitude, like they have an amount. You can have a certain amount of area, you can have a certain amount of volume, you can have a certain length, or you can have a certain temperature. But what's different about vector quantities, so a vector quantity could be something like velocity or force. And what's different about velocity and force from the other measurements we just saw is that these have magnitude, so they have an amount, and they have direction. Okay, so magnitude and direction. That's what makes a vector quantity different from a scalar quantity. Okay, so let's talk about some notation for vectors. All right, so some notation. Well, first of all, you can draw a point. Let's call this P. And then draw an arrow to another point. That's Q. And you've drawn a vector. All right, and we can call this vector PQ. So that's one way that you could write it. But another way to write it that's more common is we use letters like U. And in a textbook, you might see this U as bolded. Okay, so this is my attempt to make a bold U. But you can tell that that's a little not so nice for handwriting. Maybe convenient for typing, but not handwriting. So another two notations we tend to use, we'll use like U bar, or sometimes we'll use a U hat. All right, and those two are just different ways of saying this is a vector. Now, if we're in the vector section and you see the letter U, it probably means a vector, even if it doesn't have the bar or the hat with it. Now, what does a vector look like? Well, let's take our PQ vector and put it on an XY coordinate and then take a look at what it looks like. So, you've got a Y, you've got an X. All right, and let's take this vector and use a different color so it stands out a little bit more. And if I draw this vector PQ, so here's P, here's Q, then we can also say that whatever the coordinates of this point are, we can call them A1, A2. And A1 is an X value, and A2 is a Y value. We can also represent this as the vector U, or U bar, or I could say U hat, equals, and we use these pointy brackets, A1, A2. And what A1 tells us is the horizontal distance, and the A2 tells us about the vertical distance. And together they tell you how long the whole vector is. All right, so that's some notation that we're going to come back and use frequently. So it's just good to know what folks mean when they use different symbols. All right, so let's go ahead and start with some addition and subtraction of vectors. So when we look at addition and subtraction of vectors, we have this formula right here. If I have one vector plus or minus another vector, that's going to be equal to if I add the x components of both vectors and the y components of both vectors. All right, so this vector right here we could say is vector u. This one is vector v, and I could add them or I can subtract them. And that's just going to equal the x components from u and v, and then the y components from u and v. All right, so let's take a look at what this looks like with actual numbers. So we've got example 1 where we have 3 comma negative 4 plus negative 5 comma 1. Well, according to our formula, that will equal 3 minus 5 and then negative 4 plus 1, or that gives us negative 2 comma negative 3. All right. So what does this mean visually? Because I think that's really important to think about. So let's say that we have a vector, and we'll do that in the purple, and we can call this vector u. Okay, so u will be in the purple. And if I draw that on a coordinate plane, I'm going to start at the origin. I'm going to go 3 units to the right and 4 units down. And when I connect these two, that will give me vector u. Okay. Now, let's take a look at the second vector. We'll go with orange. So we can call this vector v. Now vector v, since we're adding it to vector u, we're going to start where vector u finished. And so from here, we're going to count 5 to the left. So 1, 2, 3, 4, 5. And we're going to count 1 up. And we're going to connect those. And we've got in orange our vector v. So if we go back to blue for our u plus v, we said that that was negative 2 comma negative 3. Well, from this origin, if I go negative 2 and negative 3, look at where I end up. I end up at the same place I would have ended if I did u plus v. So this is, the blue one is u plus v, all right? And so when we're adding together two vectors, we're kind of making two sides of a triangle, and we need to find the third side. And let's take a look at what it looks like when we are subtracting two vectors. So we'll start with the purple one, okay? And then we'll go to the orange one. And we'll finish with the blue. So this is our u in the purple. This is our v in the orange. And we're going to draw the purple one first. So 3, so we start here, we count over 3, down 4, and we connect those, and that is my vector u. Now, for the orange one, it's 2 comma 1, but since I'm subtracting it, I need to do the opposite. So I don't want to go 2 to the right, but from here I actually want to go 2 to the left and then down 1. Because again, I'm switching the signs because it's minus. And so vector v looks like this. Okay, so if that's vector u and that's vector v, then vector u minus v must start here and finish here. So that blue one is u minus v. So according to my picture, u minus v is equal to, let's see, I went over 1 and I went down 5. Well, let's see if that's what I get when I subtract them using the formula. So 3 minus 2, negative 4 minus 1. And that gives us 1 comma -5, which is good because that's what we got when we drew the diagram, okay? So we don't always need to draw the diagrams to answer the questions. In fact, it's usually pretty straightforward arithmetic, but I think sometimes just knowing what you're doing, like seeing a visual of it, helps it stick a little bit better in your brain. Okay, so let's move on to something called scalar multiplication. So in scalar multiplication, we have this rule that says if I have a number in the front, m, and I multiply it by the vector, I can basically distribute that m to the horizontal component and to the vertical component. Okay, so this m gets distributed here, and that's why I get m times the horizontal component and then m times the vertical component. So let's see what that does if we follow the formula, and let's see what it does when we draw the graph. So 2 times this vector will give me 2 and then -4. And if I do the same thing in example 3, it's almost the same, but it's going to be -2 and a +4, okay? So let's draw the original vector, and I'm going to draw the original vector in orange, all right? So we'll have the original vectors in orange on both graphs, so let's draw those. So I go 1, down 2, so that is vector u, okay? We'll call this vector u. I'm going to draw the same thing over here because it's the same initial vector, and again, that's vector u. All right, now in the blue, I'm going to draw the scalar multiple. So if I want to draw 2 comma -4, I'm going to start here, go over to the right 2 and down 4, and I'm going to go right on top of this other vector, but this one, which is 2u, is in the same direction, but it is twice as long, okay? So same direction, but twice as long. Okay, well, let's see what happens in example 4. I want to plot -2, +4. So that's going to mean I draw one kind of like this. And this is -2u. So what does that tell us? Well, -2u is twice as long, but pointing in the opposite direction. All right, twice as long, but pointing in the opposite direction. And that's what that negative means. That negative flips the direction 180 degrees. So let's go ahead and stop here. When we come back, we'll take a look at some properties of addition and scalar multiplication, and then we're going to move on to some magnitude and direction work. See you back here.